first of all, let's understand, let's say a standard linear equation. Which is ax plus by is equal to c. Let's say there are two equations. So we have a1x plus b1y is equal to c1. Other is a2x plus b2y plus c2, right? Taking examples of it, 2x plus 3y is equal to 5, x plus 2y, let's say, is equal to 3. So first of all, how do we solve it? What do? We make one of the equations, one of the coefficient of the variable equal, right? And then we cancel it out. For example, if I multiply this by 2, this will become what? 2x plus 4y is equal to 6. What is the first one? 2x plus 3y is equal to 5. Now when you solve it, subtract it, what do you get? Minus y is equal to minus 1, or y is equal to 1. You substitute it back here in the first equation, let's say. So what do you get from here? 2x is equal to 5, y is equal to 1, so 5 minus 3, that is equal to 2. So x is equal to 2. So when you find out the, sorry, x is equal to 1, my bad. Is equal to 1. So when you have to solve it, what is the solution you get? 1 comma 1. X comma y is 1 comma. This is how you always represent. How do you represent x comma y? Now what you have to understand is, what does it represent in a graph? When I talk about a linear equation, what does it represent in a graph? So in a graph, a linear equation represents a straight line. In a graph, a linear equation represents a straight line. So then what is the solution that we found out? What does the solution mean? The solution means number of, basically point of intersection. This solution is nothing but point of intersection. This is what this point means. So now understand this. When you said these two lines, they intersected 1 comma 1, it was like this, right? One line here, one line here, they intersected somewhere here, right? Now when you see this, is this the only possible cases when there are two lines, two straight lines? No, right? There are other cases. What are the other cases? There's one more case wherein one line is here and the other line is here, exactly parallel to the first line. Now if that is the case, what will happen? They will not intersect at all. So there won't be any intersection point, no intersection points at all. What is the third case now? The third case is wherein there's one line. The second line is parallel to the first line, but it is completely overlapping on the first line itself. It is completely overlapping on this line. So what happens now? Every point is an intersection point, right? Every point is an intersection point. So now there are names given to these cases. What is the first case? This is a unique solution case. Unique solution case. This one is no solution case. No solution was not touching. This one is infinite solution case. Infinite solution case. Why is this now? So this is touching at a unique point, so it is a unique solution. This is not touching at all, so no solution. This is every touch point is a solution, right? So infinite solution, right? Now how do you represent this? So let's understand the formula here. You don't need to mug it up. Every time we get to know, we have to mug it up, but let's understand the reason behind the formula. So you will never have to mug it up once you know that. So now what do we have here is, understand this, coefficients of x and y, which is a and b, they represent the slope of the equation. What is the slope of an equation now, or a slope of a line? What is that? That is the angle that the line makes with the positive x-axis. Let's say this is my x-axis, this is my positive x-axis, and this line, there's this line. So what would be this slope? Slope is basically the angle that the line makes with the x-axis, this theta. This theta, slope is nothing but tan of theta. So it's the angle that makes that the line makes with the positive x-axis. So when two lines are parallel, their slope would be equal. If the two lines are non-parallel, their slopes would not be equal. We'll discuss this in detail in coordinate geometry, but right now you can understand when two lines are parallel, their slope will be equal. So A and B represent the slope of the line, whereas this constant part C, that represents the position of the line. Right? This constant part represents the position of the line. Now listen to this very carefully. When I talk about unique solution, okay, let's do it here itself. So when I talk about unique solution, what happens? See, these two lines are not parallel, right? That's why there's a unique solution, that they are not parallel. If they're not parallel, so simply what happens is A1 by A2 will not be equal to B1 by B2. Nothing to do with the C part. Simply A1 by A2 will not be equal to B1 by B2, which means that which coefficient of X here, coefficient of Y here. A1 by A2, if it is not equal to B1 by B2, which is unique solution. Now you have to understand this in a vice versa fashion. If there are two equations and you see A1 by A2 is not equal to B1 by B2, you have to understand it's a unique solution case. Second is if A1 by A2 if they tell you in a question that it's a unique solution case, you have to understand A1 by A2 will not be equal to B1 by B2. Correct? Talking about no solution. No solution is what? They have to be parallel. So A1 by A2 should be equal to B1 by B2. They have to be parallel, right? But their positions are different, right? That is why it is not equal to C1 by C2. Now you can remember, right? Now no need to mug it up. You know the reasons. No solution when they are parallel. So A1 by A2 has to be equal to B1 by B2, but they are at different positions, right? That's why C1 by C2. And infinite solution now is easy. They are parallel, so A1 by A2 is equal to B1 by B2, and it is at the same position, so it is also equal to C1 by C2. So these are the conditions, vice versa. Now you know it. How do you do it? So don't need to mug it up. Just understand it where it comes from, and you'll remember it for the lifetime.